All right, let's talk about correlation and causality. So this is the last section of this chapter, chapter 5. So let's jump right in. Okay, so now the definition of correlation is that it is a relationship between two variables. That's what we mean by a correlation. Is there an association of some sort between two variables? So when there is an association between two variables, we say that those variables are correlated, or there exists a correlation. So the definition says a correlation exists between two variables when higher values of one variable consistently go with higher values of another variable, or when higher values of one variable consistently go with lower values of another variable. So those are two different types of correlation. One's positive, one's negative. Okay, we'll talk more about that momentarily. Now, examples of correlation. So there is a correlation between variables of height and weight of people. Taller people tend to weigh more than shorter people. Okay, so that's a correlation. There's a correlation between variables of demand for apples and the price of apples. Demand trend tends to decrease as prices increase, right? So the higher the price something goes, the less likely people are willing to buy them. Okay. There's a correlation between practice time and skill among piano players. So the more time you spend practicing, the better at that skill you will become. So how do we determine whether there's a correlation? Well, the first thing we start with is a scatter plot, a graph, right? So we always start with a graph, and the type of graph that we use to determine whether there is a correlation is a scatter plot. Okay, so now here are the different relationships that we could have. We could have no correlation. There would be no apparent relationship between the two variables. We would say that means that there's no correlation. A positive correlation means that both variables tend to trend in the same direction, either both going up or both going down. And the negative correlation means that they tend to trend in opposite directions. So as one variable goes up, the other variable goes down, and vice versa. And then the strength of the correlation is shown by how tightly packed around a line. And again, we're going to specifically talk about linear correlation. It is. So even if it's more packed around a line, in fact, whether it's linear or nonlinear, if it's more tightly packed, then it would have a stronger correlation. Okay. In fact, in a straight line, that would be perfect correlation. We only see perfect correlation in mathematical laws, things like that. Formulas, mathematical formulas. So here's an example of a scatter plot where there is a positive correlation. Notice how as you go left to right, so this is the weight of a diamond versus its corresponding price. So each one of these dots represents a particular diamond. So this diamond here has a particular weight and a particular price, right? So we can see that there's a trend, and you could draw a line, that there's an upward trend going left to right. So this has positive correlation. You can see that the line has a positive slope. Easy to see how that goes together. Okay, so the higher the weight, the higher the price, typically. Now, if we look here at a negative correlation, we can see that the graph shows the life expectancy, right? So this is infant mortality, deaths per 1,000, live births. Okay, so infant mortality and life expectancy. You could see that as life expectancy increases, infant mortality decreases for all these countries, right? So you can see each of these countries has a corresponding infant mortality rate and a corresponding life expectancy, okay? So it allows you to compare countries based on those two things. But if you look at these countries, it seems, based on this, that it has a negative correlation, because you could draw a line from left to right that goes down. It has a negative slope, therefore negative correlation. Now, let's look at these two scatter plots, which is talking about forecasting, weather forecasting. So the graph on the left is the same day forecast. versus the graph on the right, which is a 3-day forecast, what do you notice? Well, you notice that they both have a positive correlation, even though it seems like the one on the left has a steeper slope than the one on the right, but nonetheless, they are both positive. But also notice that the graph on the left is more tightly packed around a line, right, than the one on the right, okay? And so it shows you that, hey, there's going to be less error, right, between the actual temperature, right? So the actual temperature of the day versus the same day forecast. Then if you look at the 3-day forecast, so if you compare the actual temperature for the given day based on the 3-day forecast for that same day, you can see that there's more error, right, of the 3-day versus the same day. That should also make sense, right? So there's a stronger correlation between the forecasting, same day forecasting versus whether it's a 3-day forecast, which makes sense. So again, because it makes sense because we would expect weather forecasts to be more accurate on the same day versus 3 days earlier. Okay, so now possible explanations for correlation. One is that the correlation may just be a coincidence. There may not be a correlation at all. Or, well, what am I saying? Well, just that. It's just a coincidence, right? So the correlation may be a coincidence, and that's all it is. And then, of course, both variables may be directly influenced by a common underlying cause. Remember when I talked about lurking variables or confounding variables? So there might be another variable, z, let's say, that is directly influencing both x and y. And then one of the correlated variables may actually be causing the other. Okay. Note that even in this case, it may only be one of several causes. Okay. So one variable may be causing the other variable to respond. So those are, oops, hold on. Yeah, those are the 3 possibilities. Now, let's look at this example here. So we want to consider the negative correlation between infant mortality and life expectancy. Which of the 3 possible explanations for a correlation applies? Okay, is it just a coincidence? Is there a third variable that's affecting both, that's causing both of the variables to change among the countries, or is one variable causing the other? You know, infant mortality affecting life expectancy, or vice versa. So let's look at that. So in this case here, it's going to be due to an underlying cause, and that's going to be the quality of the health care in those countries. Notice that the countries where the infant mortality is the least, and again, the life expectancy is the greatest, are the more developed countries. They have the better health care systems, okay? So, and again, with better health care comes both lower infant mortality rate and also a higher life expectancy. Now, here are the guidelines for establishing causality, okay? So if you suspect that a particular variable, the suspected cause, is the cause of some effect, is causing some effect, then what you want to do is you want to look for situations in which the effect is correlated with the suspected cause, even while other factors vary. Okay, so that's 1. 2, among groups that differ only in the presence or absence of the suspected cause, check to see if the effect is similarly present or absent, right? Okay, so if you see something going on, you see a possible correlation, and you remove the cause of that, the suspected cause, do you see an absence of the effect? And then when you introduce the suspected cause, do you see the effect reappear? You know, play around with that. And then 3, look for evidence that larger amounts of the suspected cause produces a larger effect, a larger amounts of the effect, okay? And so that's another thing you want to do. And then 4, if the effect might be produced by other potential causes besides what you suspect the cause to be, make sure that the effect still remains after you account for all of the other potential causes. So if you are able to fix those other causes, right, keep those controlled, and see if the effect still remains by using the suspected cause, that would be another guideline. And then 5, if possible, test the suspected cause with an experiment. So if the experiment cannot be performed with humans for ethical reasons, consider doing the experiment with animals, cell cultures, or computer simulations. 6, try to determine the physical mechanism by which the suspected cause produces the effect. Okay, what is the mechanism? Okay, so let's look at this one here. Case study for airbags in children. So by the mid-1990s, passenger side airbags had become commonplace in cars. Statistical studies showed that the airbag saved many lives in moderate to high-speed collisions, but a disturbing pattern also appeared. In at least some cases, young children, especially infants and toddlers, in child car seats were killed by airbags in low-speed collisions. Okay, so there's something that popped up. Okay. At first, many safety advocates found it difficult to believe that airbags could be the cause of the deaths, but the observational evidence became stronger, meeting the first 4 guidelines for establishing causality. For example, the greater risk to infants in child car seats fit guideline number 3 because it indicated that being closer to the airbag increased the risk of death. A child car seat sits on top of the built-in seat, thereby putting the child closer to the airbag than the child would be otherwise. Now, to seal the case, safety experts undertook experiments with using dummies. They found that children, using their small size, often sit where they could be easily hurt by the explosive opening of an airbag. The experiments also showed that an airbag could impact a child car seat hard enough to cause death, thereby revealing the physical mechanism by which the deaths occurred. Okay, and so that's what changed the laws about where you could place car seats in a vehicle. Okay, so now there's got that warning not to put rear-facing car seats in the front seat or where there are airbags. Okay, so now confidence in causality. So let's talk about the different levels of causality, if you will. So one is possible cause. If you're at a level where, okay, you have a possible cause, we have discovered a correlation, okay, but cannot yet determine whether the correlation implies causality. So all we've done is basically determine that there's an association between 2 variables. In the legal system, possible cause, such as thinking that a particular suspect possibly caused a particular crime, that's often reason to start an investigation, right? So if there's a possible cause, you can start an investigation in the legal system. Probable cause, well, that means we have good reason to suspect that the correlation involves a cause. Perhaps because some of the guidelines that we've talked about have established causality, right? Maybe we've checked off some of those boxes along those guidelines. And so in the legal system, probable cause might be the general standard for getting a judge to grant a warrant or for a search or for a wiretap, okay? And then beyond reasonable doubt, cause beyond reasonable doubt, we have found the physical model that is so successful in explaining how one thing causes the other that it seems unreasonable to doubt the causality. In the legal system, this would be similar to the usual standard for conviction, right? So beyond reasonable doubt, right? The jury has said, hey, if it's beyond all reasonable doubt, okay? So it generally demands that the prosecution show how and why, essentially, that's the physical model, the suspect committed the crime. Note that beyond reasonable doubt does not mean beyond all doubt, okay? So it's beyond reasonable doubt. So the prosecution has to make its case beyond all reasonable doubt. All right, so that wraps up this chapter. So again, we'll start with getting into more details of statistics in chapter number 6. So we're not done with statistics. We're going to actually go one step further, and we're going to start getting into more of the details, and we're going to get into other areas of statistics. Okay, other than that, you have a great day, and I'll see you soon.